Okay, guys, this is the answer key to the Unit 5 practice test. We're getting started with Section 1. So this is on the simplifying trig identities, solving trig equations, and trig proofs. First one, which one of these is not true? So these are all different variations of the Pythagorean identity. Notice like this is our original. This is I was just sort of subtracting subtracting sine squared from both sides. These two are fine. But it's actually answer C that is not correct. And you could use your formula sheet to help you. But if you look at the Pythagorean identity, it's 1 plus cotangent squared equals cosecant squared, not the other way around. So C is incorrect. Which of the following is equivalent to cosecant theta? So when I multiply one of these four products together, I should get just cosecant. So we can test the first one, so just be sine times sine over cosine. Well, that's not going to simplify, right? So I can ignore that one. But if I think about secant, this is 1 over cosine x times cosine x over sine x. And what happens here is these cancel, so we'll be left with 1 over sine x, or just cosecant x. So this is my answer B. Good? Okay. For number 3, we're solving this. Solve the equation. We're going to factor out the cosine. So we have cosine theta times 2 cosine theta minus 1 equals 0. Okay. Therefore, cosine theta must equal 0, and cosine theta equals 1 over 2. So then you can go to your unit circle and see, okay, well, where is this true? Where is cosine 0? When is cosine 1/2? And you'd see that that's going to be at pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3. So this would be the right answer. Okay. All right, continuing on. Proving these identities. So to prove this identity, I'm going to start with the right side by expanding the right. So I'm going to rewrite sine squared as cosine squared minus 1 over 1. Sorry, 1, not 1, cosine squared minus 1, but 1 minus cosine squared. 1 minus cosine squared over 1 minus cosine x. Then using the difference of squares, that is the same as 1 plus cosine x, 1 minus cosine x, over 1 minus cosine x. And then these will cancel here, and I'll be left with 1 plus cosine x, which is pretty simplified. If you look at this term on the left, this is the same as 1 over secant x plus secant x over secant x. 1 over secant is cosine. Secant over secant is 1. So therefore, these two are equal. Okay. Next, we have an identity, a sum identity. So we have cosine x, cosine y minus sine x, sine y over cosine x, sine y. I can separate this into two fractions. I can write it as cosine x, cosine y over cosine x, sine y minus sine x, sine y over cosine x, sine y. These sines will cancel. These cosines will cancel, and I'll be left with cosine y over sine y minus sine x over cosine x. Cosine y over sine y, that's just cotangent y. Sine over cosine is just tangent x. So that's it. That's what I wanted. I'm done. Okay, last one. We have sine 2x minus cosine 2x. So you can use your identities. Sine 2x is just 2 sine x cosine x. Sine x minus cosine 2x. Well, you have different options, but if I wanted to cancel out with the cosine x, it makes sense to use the cosine version. So if you look here, cosine 2x is equal to 2 cosine squared minus 1. So we're going to use that one. 2 cosine squared x minus 1 over cosine x. Okay, let's simplify this. Well, this is going to cancel. It's just 2 cosine x. See that? Then I'm going to split this up to be minus 2 cosine squared x over cosine x. And then we have a double negative here, so then plus 1 over cosine x. 2 cosine squared x over cosine x, that's just 2 cosine x. Right, so these two are the same thing. So together, this is just 0. And 1 over cosine x, that's just secant x, and I'm done. That's it. That's what I wanted. Okay. All right, we're on to section 2, solving the triangles. This is going to be using law of sines, law of cosines, and then the area formulas. So, first one, we have, I think it's good to start with what kind of triangle is this? Well, this is an AAS triangle. So AAS, you should think that's law of sines. Okay, so we can set this up as x over sine 45 equals 2 over sine 105, and we're just going to get x alone. So x equals 2 sine 45 over sine 105. And so my answer is A. Okay. For number 2, consider triangle XYZ with angle Z is 107, X is 5, and Z is 15. So let's draw this out. So this is an SSA, but it's an obtuse SSA. So if we look at this is 15, this is 5, and this is 107 degrees. So remember from your notes, if it's obtuse, it's either one solution or no solution. And the requirement is that this opposite side has to be greater than this adjacent side. Okay, so if there's one solution, I can see it here, I'm just going to use law of sines as normal. So we're going to say, well, what do I need? I need another angle. So let's go for this angle here. Okay, so we'll say that sine 107 over 15 equals sine x over 5. So it's going to be 5 times sine 107 over 15. On the calculator, on the calculator, that's going to be 5. Oops. Let's go here. There we go. 5 times sine 107, make sure in degrees, times 15 is, nope, 5 times sine 107 divided by 15. There's 0.31, take the inverse sine of that. We get 18.6 degrees. So if you look at your options, you can see that it has to be C. Okay? All right. Questions 3 and 4, we're just looking at one triangle. First is just, what is the smallest angle of this triangle? Well, the smallest angle is going to be here. And because it's a side, 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 you're going to use law of cosines, LOC, right? So we're going to say, we can just pull this from our formula sheet, that cosine of, we can call this x, sure. Cosine x is going to equal 13 squared plus 20 squared minus 9 squared over 2 times 20 times 13. Okay. Let's do it on the calculator. 13 squared plus 20 squared minus 9 squared divided by 2 times 20 times 13 is 0.938, and when we inverse cosine that, we get 20.2. Okay, so cosine x equals 0.938, and then we took the inverse of that, x equals 20.2. So the answer is A. Okay. To find the area of this triangle, it's an SSS. We're going to use Heron's. Okay, Heron's again is 1/2 A plus B plus C is S, and then root S minus A, S minus B, S minus C. Okay, so let's do that. So it's going to be S is 1/2 times 20 plus 9 plus 13. That should just be 21. And then we'll do here 21 times 21 minus 9 times 21 minus 13 times 21 minus 20. Okay, so let's do that. 21 minus 9 times 21 minus 13 times 21 minus 20 times 21 square root. I'm getting 44.9. So it must be B. Okay. All right, last page for your response. In order to save the planet from the evil space toads, Celia must solve the following triangles. Help her save the planet, show all the work in a clear and organized manner. Okay, so we need to find everything about these triangles. We need to find all the side lengths and all the angles. Okay, so let's start just by drawing this, and let's identify what we have here. We have an SSA, right, and we have an acute SSA. So if you remember, for acute SSA, this is where we have our three different possibilities. So this is going to be 45 degrees, this is going to be 28, and this is going to be 22. Okay. So we need to, before we go any further, check the height of an SSA to make sure that it's not no solution, or it could be two solutions. I mean, we can see here that this side is not greater than 28, so it's not that case. It could be no solution, or it could be two solutions. Let's find out. So to find the height is equal to sine 45 times 28. Let's figure that out. Sine 45 times 28 is 19.8, right? So what that means is that because this opposite side is bigger than the height but less than the adjacent, we're actually getting these two triangles here. So we get this triangle and this triangle, okay? Let me kind of finish labeling. So we're going to have B here. This is going to be like our A1, because this is our little a over here. And then this would be our big C, or there's kind of going to be like a C1 here and a C2 here. And then there will be an A2 here, okay? So there are these two triangles. This triangle here, and then this triangle here, okay? So let's start with finding A1. We're going to do law of sines. So we're going to say sine 45 over 22 equals sine A1 over 28. So when we solve that, we'll get 28 times sine 45 divided by 22. And then we'll inverse sine that. And we get A1 equals 64.2 degrees. So that means that this value right here is 64.2 degrees. That means that if this is B, then C1 equals 180 minus 64.2 minus 45. 70.8. Okay, so I have, let's like write out the whole triangle now. So this triangle would be A1, B, and C1, and then we have little a, little b, and little c. A1 is equal to 64.2, B is equal to 45, and C1 is equal to 70.8. Little a is equal to 28, little b is equal to 22, and little c we can solve using law of sine. So we'd say sine, which we can do is 22 over sine 45 equals c over sine 70.8. We get C is 29.4. So a good thing to check is to make sure that the larger angles are associated with the larger sides and the smaller angles with the smaller sides. So this triangle is done. Okay. Then let's set up our other triangle in which we know it's an A2, which we'll get in a second. That's going to be, let's do it now. It's going to be just 180 minus A1, which was 64.2, which is 180 minus 64.2, 115.8. Okay. Then we have B is still 45, and then we have C2 is going to be 180 minus 115.8 minus 45. Which is 19.2. And then little a is still 28. Little b is still 22. And then we'll do the same process to find little c. So little c will be 22 over sine 45 equals little c over sine 19.2. When we solve that, we'll get 22 times sine 19.2 divided by sine 45 is 10.2. And we're done. So if you have two triangles, you should have these two neat sets of coordinates, one for the angles and one for the sides. Okay, we're on our last problem. Let's draw out the triangle, RPQ. We have P is 18, let's call this P. We have R is 17, let's call this going to be our R. And then we have Q is 28. So we need to find big Q, big P, and little r. Okay, so we have an SAS triangle. We don't have an angle on the opposite side, so we have to use the law of cosines. Have to use law of cosines. So let's start by finding r. Okay, r squared is going to equal 18 squared plus 28 squared minus 2 times 18 times 28 times cosine 17. Let's go ahead and solve this. So I'm going to use my calculator here. 18 squared plus 28 squared minus 2 times 18 times 28 times cosine 17. And then I'm going to square root that. I get 12. R is 12. So it might be nice if you want to stay organized. Let's like set up our kind of what we need over here. So we need R, we need P, we need Q, and we need little r and little p and little q. Big R is 17. Little r is 12. Big P we don't know. Little p is 18. And then little q is 28. Okay? Now we'll do law of sine. Now we can use law of sines to find big P and big Q. We can say that 12 over sine 17 equals, well, I'll do it the other way around. Sine 17 over 12 equals sine P over 18. We're going to solve this for sine P, so 18 times sine 17. Divide that by 12, inverse sine it, and we get 26 degrees. Okay, so P is 26 degrees, and this makes sense, right, because 17 is 12, 26 is 18. Okay, this seems reasonable. And so that means that Q must be, we can just do 180 minus 26 minus 17 is 137. And if you want to check that you're right at the very end of the day, like make sure you get all right, sometimes there can be ambiguous answers because of the range of sign. You may have found that you got a different answer here. But you may have gotten like 43 if you solve for a big Q. But that cannot be, because then P would have a larger angle but a smaller opposite side. So you want to make sure that your angles match the length of their opposite sides. And if you want to double check completely, you can always just do, okay, well, is sine 17 over 12 equal to sine 26 over 18 equal to sine 137 over 28. Make sure all those are equal at the end of the day. Like that, you can check your triangle. Okay? All right, that's it. Good luck on the test, guys.
Thank you.